Hi everyone, I'm going to discuss systems of linear inequalities. So last time you learned about sketching the graph of linear inequalities in two variables. So it would be easier for you now to understand how we work on the solution on the systems of linear inequalities. So previously, you learned how to solve a single linear inequality by graphing. In this article, we will learn how to find solutions for a system of linear inequalities by graphing two or more linear inequalities. So just to recall, if like we have, if we're using the less than or less than or equal to inequalities, if let's say this is the line of the equation. So we are going to either work on the solution by identifying the shaded region or we consider as the area. So usually if it's less than or equal to the shaded region or the area will be below the line. On the other hand, if it's like we're using greater than or equal to. So particularly for this example, this is making use of less than or equal to because the line that we are using is a solid line. In the event that we're using less than, so this must be a broken line. So for this one, the shaded region or the area must be above the line. And take note again that a system of linear inequalities is a set of equations of linear inequalities containing the same variables. Now, what is again the difference between linear equations and linear inequalities? So, look at the graph. If we're going to compare linear equation and linear inequality defined by y equals 3 halves x plus 3 and y is less than or equal to 3 halves x plus 3. So the linear equation gives a line graph, this one, while linear inequality shows the area of the coordinate plane that satisfies the inequality. The area is the shaded region. So meaning the solution set or the solution for linear inequality is consists of a set while the solution for linear equation is since this is linear, so will give us only one solution. Now, before we come up with working on the solutions for the systems of linear inequality, let's recall some properties of inequalities that will be helpful for us. So, inequalities are solved with the following properties of inequality for real numbers a, b, and c. So, if a is less than b, then a plus c is less than b plus c. So, take note that whatever constant value, same value we added on both sides of the inequality, for instance, C here, so the inequality remains the same. So the left side will remain as less than the right side for that example. So particularly, we consider that as addition property of inequality. If A is less than B and C is greater than 0, then A times C is less than B times C. So from the original inequality here, A is less than C. And then there comes C greater than 0, meaning C here is the set of positive integers. Now, the inequality remains the same. It's 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 still less than inequality as we add or as we multiply the same factor, which is c greater than 0. So this only implies that c is a positive integer. So for example here, we have a equals 2, b equals 3, and we multiply each side of the inequality by the same factor 4. So the inequality remains the same. So this is about multiplication property of inequality with c greater than 0. It's a different case class whenever c is less than 0. Okay? So take note that the original inequality that we have used is less than. Then as we multiply a constant factor on both sides, c, whenever c is less than 0, meaning c is negative integer, then the inequality will be reverse and it will turn out to be greater than. For example, whenever a equals 2, b equals 3, and then we assign c equals negative 4, which is less than 0, then as we multiply both 2 and 3 by negative 4, we have to reverse its inequality. So we'll come up with the value here, negative 8 is greater than negative 12. So we know that as negative integers increases, the value decreases. So therefore, negative 8 is greater than negative 12. So let's consider the steps in solving linear inequalities. First, we have to isolate the variable y in each linear inequality such that inequality would form a slope-intercept form wherein y equals mx plus b, where m here is defined by this formula. And m in the previous discussion is the slope. And b here is the y-intercept. And then we're going to draw and shade the area above the borderline using dash and solid lines for the symbols greater than and greater than or equal to respectively. So we're gonna use a dash line for greater than if there's an inequality on if there's an equal sign for this inequality, then it has to be a solid line. And then draw and shade the area below the borderline. Use dash and solid lines for the symbols less than and less than or equal to respectively. Shade the region where all the equations overlap or intersect. If there's no intersection, then we can say that the system of inequalities has no solution and we consider that or we categorize that as inconsistent system. Okay, so I guess we're ready in graphing. So here, we're going to find a solution for this system. So what we're going to do first is to isolate y and convert this in terms of the slope intercept form. So as we transpose x on the other side, this gives us y is greater than negative x plus 7. And then this one, so if we are just going to transpose this on the other side, this on the other side, this gives us 3x minus 1 is greater than y. Or this is the same with y is less than 3x minus 1. Or it's the same idea as you transpose 3x on the other side. So this gives you negative y is greater than negative 3x plus 1. And then you divide both sides by negative 1. Since you divide a negative value on both inequalities, we are required to reverse the inequality symbol. And we will still come up with this inequality. Y is less than 3x minus 1. Now, what we're going to do is consider this inequality as if this is an equation, and we will begin with plotting or identifying the y-intercept of each inequality. For example, we have 0, 7 here, and then we're going to consider the slope of the first inequality, which is equal to the coefficient of x, -1, and this is equal to -1 all over 1. So we will move down by 1 unit from this point and run by 1 unit to the right. So if we move down by 1 and then we run by 1, so we have this point already. So connecting the 2 points and making use of the dash line, since this is greater than, so we'll come up with the dash line for the first inequality. Now, since this is greater than, what we're going to do is to shade the region above the dash line. So we're going to, let's make use of a different color here. So this is the shaded region or the area for this inequality. And then for the second inequality, the y-intercept is -1. So one point is at 0, -1. And then the other point is defined by the slope, which is equal to 3. So this is 3 over 1. So we will run, or we will rise by 3 units up from this point, 1, 2, 3. And then we will run by 1 to the right. So connecting the 2 points now by a dash line again. So we come up with the dash line represented by this inequality, and we will shade the region represented by this inequality as the solution. Since this is less than, we're going to shade the region below this dash line. So let's make use of another color here. Okay, here. Now, class, the solution wherein the shaded regions overlap is the solution for this system. And let us shade this by another color. So this is now the solution. Okay, next. Now we have x is less than or equal to 2, y is greater than 1. Take note that both inequalities have only one variable. So either the inequality is a horizontal line or a vertical line. For x is less than or equal to 2, meaning we'll come up with 2 as the constant value. So here, and then we will draw a vertical line along with this 2, since this inequality has an equal sign less than or equal to. And then the shaded region will be from the left of this vertical line. So so this must be the solution. So it should not exceed the line. Okay. There. Now, on the other hand, the graph of y is greater than 1 is a horizontal line. And then we'll consider the boundary 1 here. So it's a horizontal line such that the horizontal line will intersect this y equals 1 here. And we're going to make use of a dash line there. Since this is greater than, it should be above the dash line. So let's make use of a different color here. So the overlapping region is the solution for that system, which is represented by this, okay, blue region. So this is the solution set. Oh, by the way, let's go back with the first example there. Now, from the overlapping region, if we're going to select any points, it should satisfy both inequalities. Like if we're going to select here, if we're going to select 8, 0, so H0 must satisfy both inequalities. So as we substitute 8 to x and 0 to y, we have 8 plus 0 is greater than 7. So really, 8 is greater than 7 is true. Likewise here, 3 times 8 minus 0 is greater than 1. So this is 24 is greater than 1, which is also a true statement. So all these points on the solution set for the system must satisfy both inequalities, meaning as we substitute each of the points represented by the solution of the system to both inequalities, we will come up with always a true statement. Okay. So here, if for example, we're going to select a point from the solution of this system, if like we're going to consider 0, 2, and we will substitute 0, 2 to both inequalities, like since we only have x on the first inequality, so 0 is less than or equal to 2. So this gives us a true statement. Likewise, 2, which is y, is greater than 1 is also a true statement. And this is also true with the other solutions here when you substitute each of the solutions to the inequality. So it should satisfy both inequalities that we will be coming up with a true statement. Next is number 3. So what we're going to do is to make this as in the form of the slope intercept. So we're going to isolate y. So we have 2y is greater than negative 4x plus 8. So we will divide both sides by 2. The inequality will remain greater than since we are dividing both sides by positive values. So we now have y is greater than negative 2x plus 4. For this, we have negative 3y is less than negative 9x plus 15. So we will divide both sides by negative 3. So the inequality will be reversed. So we have y is greater than 3x plus 5. So both inequalities here are in the slope intercept form. So we can easily sketch the graph of each inequality by using either a dashed line or a solid line. But in this case, we're going to use both dashed lines. So we're going to consider the y-intercept for the first inequality 0, 4. And then from this point, we're going to consider the slope, which is the coefficient of x, -2. So this is -2/1. So we will move by 2 units down from 0, 4 and then run by 1 unit to the right. So this is the point. So we're going to connect the points by a dashed line. So we got that. Also, 0, 5 here. And then m is 3 or 3/1. So we will rise by 3 units up, or this can be -3/-1, or we will move down by 3 units from 0, 5. So 1, 2, 3, and we will run to the left by 1 unit. So this is the other point. So we'll connect the 2 points by a dashed line. So we get this one. We have to know that this is -3. So this must be -5 instead of +5. And of course, we got the same slope. We either use this or this. So the y-intercept is at 0, -5. So this is the point. And then if we're going to rise by 3 units up, 1, 2, 3, and then 1 unit to the right. So we connect the 2 points here. So we got this dash line. Now, it's necessary first that we have to shade the region, like for the first inequality. So this is greater than. So it must be above this one. And then it's less than for the second inequality. Okay. So the overlapping region must be considered as the solution set for this, which is this portion. Oh, for a while. I think I have to change the color. Okay. I made use of red here. And then for this, it's a bob. So maybe we can use like blue. Okay, here. So probably the checkered portion is the solution set. So for example, if we're going to select one point there from the solution set, let's consider 5, 0. So 5, 0 should satisfy both inequalities here, like as we substitute 5 to x and 0 to y for the first inequality. So this is like, so this is 20 is greater than 8, which is a true statement. On the other hand, we have 9 times 5 minus 3 times 0 is less than 15. So this is 45. Okay, so let's proceed to the fourth example. So we have y is less than 3. So it's a horizontal dash line represented by the inequality. And we're going to consider 3 here. So the graph is a horizontal broken line or dash line. Now, the shaded region will be below this horizontal line. So we have the graph shaded region represented by this. And then we have x is greater than negative 2. So from negative 2 here, we will draw a vertical solid line. So this is the graph for this inequality. And we're going to shade the right portion of the vertical line to represent the solution set for that inequality. So we have this, 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 and this. And lastly, this is already in the slope intercept form. So we have the y-intercept equal to negative 1. So here, and then we will be needing another point, which can be obtained by considering m equals 1, which is the coefficient of x and will represent as the slope. So this is the same with 1 over 1. So from this point, we will move up by 1 unit and run by 1 unit. So we got another point. Connecting the 2 points, we have this. And since this is greater than, we're going to draw another, we're going to shade the upper portion of this dash line. And let's use another color. Okay, here, here, here. Now, grade 8, the overlapping region or area would be the solution for the three inequalities. And these are the solution. This portion, which is represented by, which is in triangle form. Okay. Now, the origin is considered as one of the solution for this inequality. Now, if we're going to substitute 0 to x and y, so we'll come up always with the true statement. Like here, we know that 0 is less than 3, so this is a true statement. While 0 will always be equal to any, will always be greater than any negative integer. And this is when summarized, 0 is greater than negative 1 because this will remain 0. So we have 0 is greater than negative 1. So this will remain as a true statement also. So basically, finding the solution for the system of linear inequalities require us first to solve the system in the form of the slope intercept form. And then draw a line or a dashed line represented by each inequality. And then shade the region for each inequality represented by the solution. And then the overlapping region would be considered as the solution. In the event that there is no overlapping or intersection of the solution, then there is no solution for that system and we consider that system as inconsistent. So that is for now.